Have you ever wondered how electrical devices stay safe during a short circuit? The answer lies in a small but powerful device called an electric fuse. A fuse is an electrical or electronic safety device designed to protect circuits from overcurrent and overload conditions. Fuses are used widely to safeguard electrical systems during electrical faults. While various types of fuses exist, their fundamental function remains the same. That is, to interrupt the flow of current when it exceeds a predetermined limit. In general, a fuse consists of a low resistance metallic wire enclosed in a non combustible material. It is used to install in series with a circuit or device which needs to be protected from short circuit and overcurrent. Electrical appliances may be damaged in case of absence of the fuse as they are unable to handle the excessive current according to their rating limits. The working principle of a fuse is based on the heating effect of current. That means whenever a short circuit or overcurrent occurs, then the thin wire inside the fuse melts because of the heat generated by the heavy current flowing through it. Therefore, it disconnects the power supply from the connected system. In normal operation, fuse wire is just a very low resistance component and does not affect the normal operation of the system connected to the power supply. For example, here you can see a lamp is connected across a supply through a fuse. When switch turns on, the lamp will glow. Now suppose a short circuit fault occurs in the same circuit. Due to this short circuit fault, the current flowing through the circuit will increase several times that of the rated current. A fuse wire detects this fault and it melts before reaching to the lamp. Therefore, it disconnects the power supply from the connected lamp. Now, we will see the different types of the fuses. The fuses are mainly classified into two types. They are AC fuses and DC fuses. The DC fuse opens or breaks the circuit when the excessive current flows through it. The only difficulty with the DC fuse is that the arc produced by the direct current is very difficult to interrupt because there is no current which touch the zero instant. Now, to learn why zero instant current is important for interruption of the arc, watch my video how electric arc is produced and how to extinguish that arc. Link is available in the description box. The AC fuses are categorized into two types. They are the low voltage fuses and high voltage fuses. The frequency of the alternating current changes its amplitude continuously. The current touches the zero instant 100 times in 1 second in a 50 Hz cycle. Thus, the arc extinction in the AC circuit can be done easily as compared to the DC circuit. The low voltage fuses are further divided into revariable fuse, cartridge fuse, dropout fuse, striker fuse, and switch fuse. Revariable fuse is mostly used in the small circuit or for domestic wiring. The fuse case and the fuse carrier are the two main parts of the revariable fuse. The base of the fuse is made up of porcelain and it holds the wires which may be made up of lead, copper or aluminium. The fuse carrier can be easily inserted or taken out in the base without opening the main switch. In a cartridge type fuse, fuse element is totally enclosed in a container and therefore it is also called as totally enclosed fuse. It has metal contacts on both sides. These fuses are further classified as D-type cartridge fuse and the link type cartridge fuse. The main parts of the D-type fuses are the base, adapter ring, cartridge and a fuse cap. The cartridge is kept in the fuse cap and the fuse cap is fixed to the fuse base. The cartridge tip touches the conductor when it is completely screwed to the base and thus completes the circuit through the fuse links. Link type cartridge fuse is also called as high rupturing capacity or HRC fuse. In such type of fuses, the fuse element carries the fault current for a long duration. If the fault is not clear, then the fuse element will melt and open the circuit. The major advantage of HRC fuse is that it clears low as well as a high fault current. HRC fuse has the high speed operation and also does not require maintenance. But the fuse element of the HRC fuse needs to be replaced after each operation. And it also produces the heat during the faults which will affect the operation of the nearby switches. The enclosure of the HRC fuse is filled with powdered pure quartz, which act as an arc extinguishing medium. The silver and copper wire is used for making the fuse wire. For increasing the breaking capacity of the fuse, two or more silver wire joined in parallel with each other. These wires are adjusted in such a way that only one wire will melt at a time. The HRC fuse is of two types: knife blade HRC link fuse and bolted type HRC link fuse. In knife blade type switches, the fuse wire is replaced with a live circuit with the help of a fuse puller. The bolted type HRC fuses have two conducting plates which are bolted to the fuse base. This fuse requires the additional circuit for taking out the switch without getting a shock. The dropout fuse consists of a porcelain insulator, a fiberglass which is called an insulating fuse tube, and a metal conductive parts. It acts as a protective device that breaks the circuit during the high voltage surge or fault, which prevents the damage to the equipment. The dropout action means the fuse carrier hinges down, allowing for easy identification of the fault from the ground. Such type of fuse is used for the protection of outdoor transformers. A striker fuse is a specialized HRC fuse equipped with a spring-loaded pin that releases when the fuse element melts. These fuses are commonly used in industrial, motor control, and high voltage applications for reliable protection. Switch fuse is used for low and medium voltage circuits. The rating of the fuse unit is in the range of 30, 60, 100, 200, 400, 600, and 800 amperes. The fuse unit is available as 3-pole and 4-pole unit. The making capacity of such type of fuses is up to 46 kiloampere. They can safely break current of the order of 3 times the load current. High voltage HRC fuse are mainly classified into 3 types: cartridge type high voltage HRC fuse, liquid type high voltage HRC fuse, and expulsion type high voltage HRC fuse. In a cartridge type high voltage HRC fuse, the fuse element of the HRC is wound in the shape of the helix, which avoids the corona effect at the higher voltages. It has two fused elements placed parallel with each other. One is of the low resistance and other is of high resistance. The low resistance wire carries the normal current which is blown out and reduce the short circuit current during the fault condition. Liquid type high voltage HRC fuse is filled with carbon tetrachloride and sealed at both ends of the caps. When the fault occurs, then the current exceeds beyond the permissible limit and the fuse element is blown out. The liquid of the fuse acts as an arc extinguishing medium for the HRC fuse. They may be employed for the transformer protection and the backup protection of the circuit breaker. Expulsion type fuses are widely used for the protection of feeders and transformers because of their low cost. It is developed for 11 kV and their rupturing capacity is up to 250 MVA. Such type of fuses comprises a hollow open-ended tube made of synthetic resin bonded paper. The fuse elements are placed in the tubes and the ends of the tubes are connected to suitable fittings at each end. The arc producing is blown off in the inner coating of the tube and the gases formed extinguish the arc. So friends, these are the different types of the fuses. An electric fuse may be small in size, but it plays a huge role in protecting our electrical systems and ensuring safety. Remember, when current exceeds the limit, the fuse sacrifices itself to save the entire circuit. If you found this video helpful, don't forget to like, share and subscribe to the channel. Also press the bell icon to get the notification of upcoming videos. Till time, keep learning, keep growing. Thank you.